So when running open flow experiments, as we have things set up here, you will be setting your flow rate through the flow meters manually, as I described before. But you will be measuring that flow rate in the software by looking at the flow meter output here. Now you can manually walk through each channel on the switcher to check flow on each channel, and you can do that here by clicking on this manual channel and move to 2. And now if you look at the gas switcher, you can see we have now shifted to channel 2. So we set the flow rate with the flow meter here, and then we measure it in the flow meter in the software and check that it is what we are trying to set. You can walk through all these channels manually like that. Now channel 3, we're in channel 3 now. Again, you're checking the flow rate, going back to the flow monitor output, and then moving to the last channel, channel 4. We're in channel 4 here, adjusting the flow meter output. Now, one thing to keep in mind is that the flow meters are volumetric, whereas the flow monitor that's inside this unit and the readings shown in the software is mass flow measurement. So they will not be exactly the same. What's accurate is what you're seeing in the software. Once you've set all your flows, it's important to change this manual channel parameter back to 1 before starting experiments. So you can double click on that. You can either go down using arrows, or you can double click and the window will open and you can enter the channel you want directly. So we've just switched back to channel 1, and that's a good starting point. The user parameters that we have to set in this software are the number of channels, because this is a 4-channel system, but you could use less than 4 channels. So you have to enter that here. And again, you can either double click on that window and enter your number there, or you can use the arrows up and down to change it. The second thing that is very important to set at the beginning of the experiment is your dwell time. This is the time that each chamber is being measured. It's important that this dwell time is long enough so all the gas is flushed from the chamber and steady state is reached. In open flow system, all chambers have gas flow flowing through them at all times. But what happens is only the channel that's selected is being delivered to the analyzer through this analyzer out port. All the other channels will be venting at all times. So there's always flow through each chamber, but the flow is venting, and only selected channel is delivered to analyzers. So you need to select what that dwell time is depending on the volume of your chamber, the flow rate through that chamber, length of the tubing. So we recommend that people do short trial experiments over a few cycles to determine optimal parameters. The other thing you have to set up before you start experiment is mode. There are 2 modes that are available, mode 0 and mode 1. Mode 0 is the most frequently used mode. And in mode 0, you are measuring your reference at the beginning of the experiment, and then you're measuring channel 2, 3, 4, and then you go back to reference again, channel 2, 3, 4, back to reference. In mode 1, you're measuring your reference after each channel. So you would measure reference, which is channel 1 first, then channel 2, back to reference, channel 3, back to reference, channel 4, back to reference. This is useful to do if you are dealing with very unstable background and you need to monitor your background CO2 and O2 more frequently. But you have to keep in mind that in mode 1, the experiment is going to take longer, and you have to take that into account. So once you've set these parameters, you've set your flow rate, then the last thing to do is data collection. You click on this window here, and this is where you select the duration of your experiments. Do not change the units, keep them as minutes, because all the calculations are done with minutes in place, and the number of samples per minute. So in this case, we have 60 samples per minute that are being collected, but you can reduce that if your experiments are longer or increase if they are shorter. But you got to set this up before you start your experiment. And once you've done that, you are ready to collect the data, and you would start collection by pressing collect button here. Make sure that you say erase and continue, so any previously collected data is deleted, and the new experiment can proceed. And you'll see the data showing in this table, and as well the graphs will start being populated, and we'll let this run for a little bit before we come back and look at some data. But one thing to remember, that there are 3 pages in this experimental file. All the raw data is on page 1. On page 2 is where the differentials of CO2 and O2 are going to be plotted once they are calculated. And then the summary of your data is going to be shown in the last page, where the VCO2, VO2, and RQ for all the samples are going to be graphed. But we'll go through that when we talk about data analysis. Right now, we're going to collect some of this data with empty chambers, and just to show you how this experimental file is running. This video shows a stop flow setup for 8-channel system. So in the case of an 8-channel system, we have 2 flow manifolds, so total of 8 flow meters. Of course, we've got an 8-channel gas switching system, the G244, which is set up for stop flow. That means there's connection of the stop flow solenoid assemblies to the back of the switcher, and we've got 8 of these assemblies. 7 of them have the variable volume chambers connected to them in the same way that I've described earlier. Channel 1 does not need a chamber unless you're doing a treatment where you do need to have one. So all we have is the tubing just being connected back on itself. And we've got a QP651 pump providing gas to the whole system. The flow meter, rotometers on the gas flow control manifold are where you set the flow. You've got the DCU, which is connected to the gas switcher, and it sends the signal through the software to select various channels. And the gas output from the gas switcher for the selected channel goes to the S159 analyzer, gas analyzer. So as mentioned before, with the stop flow system, what is happening is the gas is being carried from the selected channel, so in this case channel 1, through the gas switcher to the S159 analyzer, and all of the non-selected channels are in the stop flow mode. So the gas bypasses these chambers and just goes directly from the flow meter through the solenoid valve assembly into the gas switcher, and then vents through these vents. So that's what stop flow means. So one thing that you have to keep in mind is when you select stop versus open flow is you have to keep in mind the activity of the animal. Make sure that you're dealing with small inactive animals which will produce oxygen differentials basically too small for the resolution of the S159 CO2 O2 analyzer. Okay, so we've got these the system all ready to go, and you would connect the software in exactly the same way. You would open your stop flow experimental file that's provided on the C404 disk. You ensure that the connection of the USB 1 and USB 2 occurs after you've opened the file. If you're unsure about the connection of the sensors, you can look at this sensor connection window, which describes what channel is connected to which sensor. In order to start the experiment, you have to first set up few parameters. Of course, one is your sampling time, data collection time. You click on this icon here to open the window. You set the duration of the experiment, the sampling rate. Do not change minutes to other units because all the calculations are done in minutes, so we need to keep that as minutes. You also need to set up the dwell time. Dwell time is the time that the system is dwelling on the selected channel. And this dwell time has to be long enough to flush the whole chamber and reach a new steady state. So flush the peak CO2 that's accumulated and the oxygen which has been consumed, in the form of a dip, and reach a new low steady state. So it should be a sharp peak. So dwell time needs to be long enough for that to happen. But also you have to keep in mind that with a number of channels here in stop flow, the dwell time is going to determine the stop time as well. So in an 8-channel system with a 2-minute dwell time, that means each chamber is stopped for 16 minutes. So you have to keep that in mind because if you're dealing with very, very small samples, that may be not long enough, or if you're dealing with more active samples, that might be a little bit too long of a dwell time. You also need to set up in the software the mode. Mode 0 is used when you want to measure reference at the beginning and at the end of the cycle. So you would measure reference, which is channel 1 first, and then you measure channel 2, 3, 4, 5, 6, 7, 8, and then back to reference. Mode 1, which is your other option, you can adjust it by either double click on this window and enter your number right here as 1, or you can use this arrow here and just click on it to change your number. Mode 1 is used when the reference or background levels are not super stable and you need to measure the reference more frequently. So in mode 1, you would measure reference first, then channel 2, back to reference, channel 3, back to reference, channel 4, back to reference, and so on. So you have to keep in mind that when you do mode 1, it takes much longer to finish your experiment. And also, your stop time is going to be much longer because you now are measuring your reference in between each sample. So keep that in mind when selecting your mode. The other thing that has to be, of course, set up is number of channels. This is an 8-channel system, but you don't need to use all 8 channels. You could use only 4, 5, 6. So you need to enter that number here. And again, you can do that by either double click on the window, open it, and enter the number of channels, or using this arrow up and down, you can adjust it as well. So those are things that have to be set up before you start the experiment. Other parameters such as event time and parameters that are set on page 2 where the differentials U2 and O2 are plotted. These parameters like O2 delay, delay low, delay high, those are parameters that are used in calculations and they can be set up after data has been collected. Okay, I'm going back to raw data here again. One other thing that I want to mention is the manual channel parameter. This parameter is used to set the flow through each channel. So you can manually go up and down here and manually adjust the channels on the system. And when you do that, you can manually go and set up your flow rate, in this case on channel 2, adjust it, with the flow meter, and then go back to the software and see what that flow actually is and adjust it accordingly. The flow monitor that's part of the S159 is a mass flow monitor, and the readings in the software reflect the accurate flow rate through that channel. So this is good to use this manual channel parameter to work through the channels manually and set up the flow rate, for each of the channels, because you can see exactly what is happening in that channel when you do that manual change. Now, it is very important that before you start data collection, you have to go back and change this value back to 1. So at the beginning of data collection, we need to start with manual channel being set to 1. When you're ready to start your experiment, you simply click collect, and the data starts immediately populating in the table and in graphs as soon as there's enough of it. And the experiment is on the go. Sometimes when you start collection, you'll see a message which says, I'll stop this for a minute, because sometimes when you start collection, you may see a message which says, it didn't show it this time, whether you want to append to previously collected data or start fresh by deleting, erasing, and start again. We recommend that you always erase and start again, and do not append, because the software will get confused in terms of what channels are being used. To finish data collection, you click stop. It's a good idea to immediately save your data when you finished collecting it, and you can go here to either save or save as, depending with whether you've named the file already. It's really good idea to always save it under a new name. And a general comment that when doing experiments with our system, keep in mind that Logger Pro does not automatically save the data when it's collecting it and running. So it's a really good idea to regularly come and save the data and make sure that it is not lost in case there is ever a power outage and the computer shuts down or there's some problem. You will lose the data if it's not saved. So when doing experiments that are running over a few hours, we recommend that you save every hour or so. When running experiments that are going over a few days, we really recommend that you actually restart your experiment every day. So have a fresh file started for each set of data for every day, and save it to make sure that you're not creating one very big file that may slow down the system depending how fast your computer is. So saving is very important because Logger Pro does not automatically save. So you have to do it manually by going to File, Save As. Okay, that's all I'm going to show here, and we will go over some data analysis in a separate video and how to set up these other user parameters.